Heyo, it's Mr. Rotwell, the Math Master, helping you master math. And in this video, let's talk about just the concepts of how do radicals simplify. What's going on? Mathematically, how are we defining this? Well, if we have the index as b, and you're taking the b root of x to the b power, notice the index and the exponent in the radicand are the exact same. B is b, okay? Whenever this happens, this expression becomes either x if b is odd or the absolute value of x when b is even. Right now, this looks scary, right? You're like, what is happening? Why are there two different pieces? This is what we call a piecewise equation. There's conditions and there's what it equals. We can dig into this later, but let me just kind of give you an example of kind of what this means. Let's take a look down here. So first thing that I want to show you before we even start here is that we know what 3 squared is. 3 squared is 9. We already know what the square root of 9 is. The square root of 9 is 3. But let's use the definition of how we simplify radicals to figure out why is the answer 3. Why? Why is what we're going for here. Well, if we're just going to go by the definition, let's figure out what is x. What is x? Is it going to be this top piece or this bottom piece? And what is b? In this case, x is our base, so x is 3. What's b? Well, b is going to be 2. But Mr. Alwell, there's no number there. But you remember, right? We're lazy in math. If we don't have an index, we know the index is 2. You see how this 2 is the same as this 2 here? B is b. That's what has to happen if we're going to simplify a radical expression. So in our case, b is 2. So we have to check, is b odd or is b even in this case? Well, b is 2. 2 is an even number. So this is what we're going for here. For example, number 1. So our answer is the absolute value of x. The absolute value of x, because b is even. What's our x? Well, our x is 3. So what's the absolute value of 3? It's just 3. The absolute value just keeps numbers positive or turns numbers into a positive number. There's more going on there, but practically that's what happens. So hey, check it. Look, we found out what we already knew. So you might be like, Mr. Otwell, what? Why are you going so crazy about all this? Well, it really comes down to when we're simplifying variables, you really have to take into account this absolute value stuff. If we have this expression here, the square root of negative 3 squared, once again, let me just point this out. This is the square root of 9 still, because negative 3 times itself 2 times is positive 9. But check it, we already know the answer is 3. So how does it become 3? Well, in this case, x is negative 3. B is 2. Remember, these have to be the same. Whatever those things are, that is b. B is 2. So because b is even here, our answer is the absolute value of x. Our x here is negative 3. So we're taking the absolute value of negative 3 though. Remember, the absolute value turns stuff into a positive number if it's not positive already. So this is 3. The reason the square root of negative 3 squared is 3 is because of this beautiful and amazing definition of how we simplify radicals. Now, if it's odd, it gets a little more straightforward. You don't ever have to deal with these crazy square roots. So if we had the cubed root of 2 cubed, realize this is just the cubed root of 8 because 2 to the third power is 8. What is x? Well, x is 2. 2 is the base. The base is x. What is b? B is 3. See, our index is a 3. Our exponent here is a 3. B is 3. Because b is odd, our answer is just whatever x is. So our x is 2. 2 is the cubed root of 8. Let's go ahead and box our other answers. Here we said the answer was 3. So the square root of negative 3 squared was 3. Here I underlined it. Let's go ahead and box that. Okay. We said the square root of 3 squared is 3. 3 here. So let's continue. We have this, the cubed root of negative 2 cubed. Now realize this is the cubed root of negative 8, because negative 2 times itself 3 times gives you a negative 8. A negative times a negative, that gives you a positive, but then you've got a positive times a negative. So that will give you a negative 8. You may not be used to having a negative underneath a radical, because you might have thought, well, radicals are square roots. But remember, it's actually a little more than that. It's not only a square root. Now we know we have cubed roots, okay? Cubed roots can have negative numbers in them, because remember, this is saying what number times itself 3 times gets us negative 8. Well, we're about to see the answer is negative 2. How? Well, let's use our beautiful and amazing definition. What is x? X is the base. The base is negative 2. So in this case, our x is negative 2. What's our b? Well, our b is found by the index, and we want to make sure our index and our exponent are the same. So b is 3. B is an odd number. So our answer is just whatever x is. What is x? X is negative 2. So what is the cubed root of negative 8? Negative 2. So I hope this was beneficial. I hope that now you get a little better feel of what radical expressions are and some common properties we'll be using so that we can actually simplify radical expressions. I'll see you in the next video.